So hello students, how are you all? I hope you all are fine. Now in this video, I'm going to reveal a very cool amazing trick to remember the shapes of different kinds of molecule. Alright, so let us start our video. See, we have to remember a number that is 21, 22, 23. Don't go for 24, enough, okay? Then 31, 32. Next, let's come to 41, 42, then last 51. All right, now you might be thinking, what are these numbers I have written here? Just see here. This is bond pair of electron. The left side numbers are bond pair of electron and the right ones are lone pair of electron. See, for example, this trick, what I'm going to reveal now, what I'm going to discuss now, this is for these kinds of molecule. For example, you are given a molecule which has 2 bond pair of electron, 1 lone pair of electron, or 4 bond pair of electron, 1 lone pair of electron. So in this manner, for this type of compounds, the trick, what I'm going to tell in few seconds, it will be useful. All right, now let us divide this number like this 2, this 1, okay? Then let us take the 3's department, 3. Alright, now let us leave these 3 numbers as one group. Now what you have to do is, now let me tell you one, let me come to the trick. You might have heard this, right? BTS, maybe. BTS, it's one of the most famous Korean band series, music band series, right? You might have heard this, BTS Army or something like that. I don't know much about it, but you might have heard about that, BTS. So you have to remember this BTS. With this BTS, a small modification. What you have to do is just add L here, small L, okay? BTS, remember BTS, just small modification. What you have to do is add L. It's a trick to remember. Now what you have to do is, see, this one is, we call B, then this will be L, this will be L, then these 2 numbers we will take it as T, then the last 3 we will take it as S. How we have to remember this? BTS, I told you, right? BTS, small modification L, BTS, small modification L. Now what it means is, here B means bent, okay? B means bent shape. Next, L means linear. It means, linear. A here, okay? A. So what it means is, whenever you come across molecule which has 2 bond pair, 1 lone pair, or 2 bond pair, 2 lone pair, then that molecule's shape is bent shape. Alright, now T means we have 2 subshapes in T. First is trigonal pyramidal, and the second one is T-shaped. Now how to remember this? How we can remember this? If you go and look in the English alphabets, which letter will come first, P or S? Of course P, right? P, R, S, P, Q, R, S, T, P, Q, R, S. First P will come, then S will come. So in this way we can remember that first trigonal, pyramidal, then T-shaped. Getting my point? First P will come, then S will come in the English alphabets. So we can remember this. Next, let us come to S. First, S means directly in your mind it should strike. First will be C-shaped, seesaw shaped. Okay, first will be seesaw shaped because S, right? So S is dominant. So first seesaw shaped. Then next, from S, what we can do? Square. Next comes square planar. Then at last we have square pyramidal. Okay, getting my point? Now if you get confused, first square pyramidal will come or first square planar will come. If you get confused with that 2 terms, then let me tell you, first L will come or Y will come. Y is the from last second letter, right? So Y and Z, last from last second letter is Y, but in the middle itself you will come across L. So first L will come, then Y will come. In this manner you can remember this, no other confusions, because many students have seen they'll get confused whether first square pyramidal will come or square planar will come. Very simple, first L will come, then Y will come, finished. Very simple, not a great hectic in that. Okay, here also first P will come, then S will come. Here L will come first, then Y will come. No more confusions. So in this manner we have learned the trick to remember whenever we come across this type of bond pair and lone pair. Now here I have discussed we have some lone pair, but what if they give you a compound, a substance or something which doesn't have any lone pair? Okay, which doesn't have any lone pair. If you come across that type of molecules, then what we will do? See, for that also we can remember. Let me tell you one thing. See, let's take 20, 30, 40, 50, 60. What is this? As I told you, the first the first number is bond pair. Second is lone pair. Here I have taken lone pair. Some lone pair I have taken. 1 lone pair, 2 lone pair, 3 lone pair. Similarly, here we don't have any lone pair. If molecule doesn't have any lone pair, if you come across this type of molecules which has bond pair but no lone pair, so for those kind of molecules, what is the shape is for this molecule? The shape is linear. Now 3 means tri. 3 means tri. So with the hint of tri, we can remember as trigonal planar. It's plain, not pyramidal, no complex. Okay, just plain, planar, trigonal planar. Tri, 3, trigonal planar. Then 4 means tetra. You might be knowing it, all these things. Tetra means 4 means tetra. So therefore tetrahedral. Then 5 bond pair, 0 lone pair. It means trigonal bipyramidal. Trigonal bipyramidal. Then at last we have octahedral. See, I have given you a hint like tri means 3, trigonal planar. We can remember this. Tetra means 4, tetrahedral. Now this trigonal bipyramidal, how to remember this? Just see here. Tri means 3, right? Tri means 3. Bi means 2. 3 plus 2, 5. Very simple. Here only we have the hint. Okay. Tri we have hint 3. Tetra we have hint 4. It means tetrahedral. 5. For 5, tri plus bi is equal to penta. That is 5. Trigonal bipyramidal. Tri plus bi. 3 plus 2 is 5. Trigonal bipyramidal. So for this kind of molecule which has 0 lone pair, and for this kind of molecule which has 1, 2, 3 or something lone pair, we have discussed the trick. Okay, this is very important trick. BTS, just add L modification. BTS modification L. BTS modification L. That's all. Okay, so in this manner we can remember the shape and we can learn the shape of all these type of compounds. Thank you. I'm going to reveal some most amazing and awaited shortcut tricks to find the hybridization. Alright, now in this video I'll be discussing with you 3 methods. How many methods? 3 methods I'll be discussing with you. Now whichever method among the 3 methods you find it comfortable, you can opt that. Okay, now let us discuss the first method to find the hybridization. Now in order to explain you the method, I'll directly go on with the examples, because if I explain you with the examples, then you can understand it in a better manner. The first example I'm taking is NH4+. How many electrons we have? 5 electrons. But here we can see in nitrogen, I'm discussing about nitrogen, but here we have plus. It means 1 electron is removed from it. Now how many electrons we are left with? 4 electrons. Getting my point? We had 5 electrons here in nitrogen, okay, but 1 electron is removed according to this plus, so 4 electron we are left with. Then we have 4 hydrogen. Just bond them. Now you might be thinking, what is this XXX? Into marks. I have indicated the electron in the form of into marks. Okay, for the electron I have bonded with hydrogen. 4 electron we had left, 4 hydrogen we have bonded. It means 4 bond pair and 0 lone pair. Now 4 bond pair, 0 lone pair, it means sp3 hybridization. sp3 hybridization. Now if they ask you the shape, if they ask you the shape, in my previous video I have already explained you how to find the shape of the molecule. See, all these things I had explained in the previous video along with the trick BTS. The trick was BTS with the modification of L. Okay, if you want to watch that video, I'll provide the link for that video in the description box. You can check. Alright, now according to my previous video, what I had explained you, if we have 4 bond pair and 0 lone pair, the shape is tetrahedral. So the shape of this molecule is tetrahedral. Okay, tetrahedral is its shape. Next, let's go to the next example. Let me take a next example as SO3 - 2. Okay, now how many electrons we have in sulfur? 6, right? 1, 2, 3, 4, 5, 6. But here we can see -2. It means 2 more electrons are being added in this. So add 2 more electrons in this. Now oxygen has two arms. Just imagine, just for example, hydrogen will bond with only one arm. It uses only one arm to bond with the neighboring atom, but oxygen use two arms. It uses two arms. It will hold the other electron, the other atom's electron, with two arms. So one oxygen atom uses two arms. Similarly, we have three oxygen atoms, so it will use how many electrons? 6 electron will use, and last 2 electrons will be left with us, that is lone pair. So totally how many we have? 3 bond pair, the last one is 1 lone pair. Okay, 3 bond pair, 1 lone pair. Getting my point? Now for 3 bond pair, 1 lone pair, in my previous video I already told you, 3 bond pair, 1 lone pair, shape is trigonal pyramidal. Okay, trigonal pyramidal is its shape. Now what is the hybridization? 3 bond pair, 1 lone pair, sp3. Okay, sp3, it's sp3. Hybridization is sp3 because 4, right? Total it's 4. Here total is was 4. Totally whatever it may be, total if we are getting 4, then hybridization is sp3. Next, let us move on to the next example. Some more interesting examples I'll be taking. Okay, SO3 again, here SO3 minus 2, here SO3. Okay, how many electrons we have? 6 electrons, right? 1 2 3 4 5 6. So oxygen uses 2 arms. It means only 3 bond pair. Only 3 bond pair we have in this. If we have only 3 bond pair, 6 electrons, 3 bond pair, it means its hybridization is sp2. Here we had total 4, but here we have total 3. If we have 3, then you have to write sp2. If we have 4, then you have to write sp3. Now what is the shape? What I told you, 3 bond pair, 0 lone pair. Where is, okay, 3 bond pair, 0 lone pair. In my previous video I had explained what is the shape. Trigonal planar. Trigonal planar. See, in the hybridization video I am including the shapes also, so it's the advantage for you. Okay, now let us move on to the fourth example. The more example we discuss, the more better we become. Let us take XeF4. Now in xenon, how many electrons we have? 8 electrons. 1 2 3 4 5 6. 1 2 3 4 5 6 7 8. Now 4 we have fluorine, so fluorine also uses only one arm. Okay, fluorine, fluorine, fluorine. Here also fluorine. So we are left with 2 bond pair, this one and this one. So 1 2 3 4, 4 bond pair and 2 lone pair. Okay, 4 bond pair and 2 lone pair. So what is the hybridization? Total how much? 4 plus 2, 4 5 6. Okay, 6 means sp3 d2, sp3 d2. And according to my previous video, if we have 4 Okay, let me discuss the trick number 2 in another page. See, trick number 2 also I'll be discussing with you along with the example. Let me take the first example, CH4 methane. Now if you are asked to find the hybridization, see the method. See, this is the trick number 2. Listen to me carefully. What you have to do is, see, what is the valency of carbon? 4 plus valency of hydrogen 1. How many hydrogens we have? 4. Multiply 4. Did you understand? What is this? This is the valency of carbon. What is this? 1. This is the valency of hydrogen. Why I have multiplied 4? Because there are 4 hydrogens. Now 4 plus 4 ones are 4. Totally it is 8. Now what you have to do is, we just have to divide this 8 with 2. What is the answer? 2 4s are 8, right? So if we are getting answer 4, it means hybridization is sp3. Alright, now let us move on to the next example. Next example, let me take ammonia, NH3. Now tell me, how many valence electron? Nitrogen 5 plus hydrogen valency is 1. How many hydrogens we have? 3, right? So 5 plus 3 ones are 3, that is 8. Now again divide 8 by 2. 2 4s are 8, 0. If we are getting 4 as answer, what is hybridization? sp3. Now let us come to the another last example. Let me take water. Let's take water. Okay, now for water, tell me, for oxygen, what is the valence electron? 6 plus hydrogen 1. How many hydrogens we have? 2. Are you getting what I am doing? First I am writing the valence electron plus hydrogen valence is 1. How many hydrogens we have? 2. So 6 plus 2, that is 8. Okay, 6 plus 2 is 8. Now what you have to do? Multiply this, divide this 8 with 2. 2 4s are 8. Again we are getting 4. Again we are getting 4. So sp3. You got the answer. See, in just 2 seconds you can solve this. In just 2 seconds with this method you can solve this. Now let us come to the last and final method. Method number 3. This method number 3 also I will be explaining you with some example. Now let us take some complex example, little tough example, CaCO3. Now what we have to do is, again same. First write the electronic configuration of carbon, calcium. What is the electronic configuration? 288. What is the electronic configuration of carbon? It is 2, 4. Of oxygen, what is the electronic configuration? 2, 6. Now we don't need all these things. We just only need the valency electron, the ending electron we need. And now just see, carbon, calcium, how many we have? 1. So multiply 1. Okay, even if we don't multiply also it's okay. 4. What is this? 4. Carbon, how many carbon we have? Only 1. Then oxygen, how many oxygen we have? 3. So 3. Now add this. 8 ones are 8. This is also 4 ones are 4. 4 ones are 4. Then 6 threes are 18. If we add this, then what we will be getting? 24. Now the rule is, if we get this answer 1 to 8, then we have to divide with 2. Next, or if we get the answer as 8 to 54. If this number lies between 8 to 54, then we have to divide with 8. Now where this number lies, 1 to 8 or 8 to 24? Of course 8 to 24, right? So this 24 we have to divide with 8. How? 8 3 is a 24, 0. We have got 3. What does 3 means? Hybridization is sp2. See, for such a complex substance, hybridization is sp2. In a very easy manner we derived it. Now let us take another last example, because video is getting long. I am ending it. Okay, last example. Let us take this H2C2H5OH. Okay, now write the electronic configuration of carbon. What is the electron configuration of carbon? 2, 4. Next, hydrogen is 1. Then oxygen, what is the electron configuration of oxygen? 2, 6. Now see how many. Now we need only large numbers, because this is the valency electron. Directly you can write valency electron itself. Just to make you understand, I have written the complete electronic configuration. 2, 4, 1, 2, 6. I have just written to make you understand. You can directly write valency electron itself. Now 4. How many carbon we have? 2. So multiply 2. How many hydrogens we have? See here, 5. 5 we have hydrogens. So multiplied by 5. Oxygen. Actually this is then this is 1. So multiplied 1. Actually here we have 5 hydrogen, and here again another hydrogen we have. So actually this is 6. A small mistake, sorry. Okay, 2 carbon we have, so I have multiplied with 2. Hydrogen here 5, here 1. Okay, this is also hydrogen, so total 6 hydrogen. I have multiplied 6. Then oxygen we have 1, so 1. Now add this. 4 2s are 8 plus 6 plus 6 1s are 6. Now the total for this is 20. Now where this lies here itself, right? Whether it lies 1 to 8, 20? No, right? It lies between 8 to 54. For 8 to 54, which number we have to divide? 8 we have to divide. So therefore 20 divided by 8. Now how we can divide? 8 2s are 16. So 4 is left. Now again divide with 2. 2 2s are 4. So 0. Now add this 2. Add these two quotients. 2 plus 2 is equal to 4. If we are getting 4, what is the hybridization? sp3. Right. Now I have finished the tricks. Now whichever trick you find it easy, you can use it. Now if you ask me, my personal opinion, okay, what I used in my examination is trick number 2. Trick number 2. What I told you, trick number 2. For carbon, what I told you, just write the valence electron, add and multiply how much ever elements, how much ever atoms we have here, just multiply and divide with 2. This is, according to me, it's very easy trick number 2. And trick number 1 is also very easy. In trick number 1, the easiest part is the easy part. Why? Because in trick number 1 we just have to write the valency electron and we have to match. But in trick number 2 and 3 we have to multiply, we have to divide, we have to add, lots of mathematical calculations we have. So in exam stress, some students might get confused and they might do wrong this multiplication, division calculations. But here in this method we just have to write the number of valence electron, we have to match, and we will get the answer very easily. Okay, for some people method 1 will be easy, for some very important. See, in this video I am going to discuss a trick with respect to oxygen containing compounds. Okay, now let us come to our trick. See here, you can see here hybridization and nature of pi bonds of oxygen. Now see, for sp, whenever you come across a sp hybridization, then remember the trick is there will be always p pi bond only. Okay, if you come across sp2 hybridization containing compounds, then the nature of the pi bonds will be one pi bond is p pi and other bond will be p pi and d pi. This is very important. One pi bond is p pi and another bond will be p pi and d pi bonding. Okay, next we will be having this 3 hybridization, that is sp3, sp3d, sp3d2. Whenever you come across this type of hybridization, its bonding nature will be all pi bonds are p pi and d pi. All the bonds will be p pi and d pi. Now to understand this concept, let us take few examples. Am I right? So always we will be taking some examples to understand the concept better, right? So let us take the first example, SO2. Now what is the hybridization of SO2? sp2. Okay, now if you want to watch a video, I have already made a video on hybridization in which I have given you 3 super amazing tricks to identify the hybridization, and I told you you can choose any one of the 3 tricks whichever you feel comfortable. Now if you want to watch that video, you can watch by clicking the description box. I'll provide the link. Now the hybridization is sp2. What I told you for sp2, how the nature will be one pi bond is p pi and other are p pi and d pi. Now let us draw the structure to understand better. See, we will be having a lone pair here. Now next to oxygen. Okay, 2 oxygen. So one will be what will be the bonding? Okay, p pi and p pi. Other will be p pi and d pi. We will be having 2 types of bondings here. One will be p pi and p pi, another will be p pi and d pi. Now next let us go to the next example, XeO3. What is the hybridization of XeO3? I have already told you, sp3, right? Now what is the shape? How the shape? Here we have oxygen, here we have oxygen, 3 oxygens, right? So oxygen will bond with 2 arms, I have already told. Now for sp3 hybridization, what is the nature? All pi bonds are p pi d pi. So all will be what? P pi d pi bondings. Now let us take some more examples. Now let me take this example, interesting example. NO2 plus positive. What is hybridization? What is hybridization? sp. See, I have taken almost all examples. First I took sp2, then sp3. So I have taken sp also, an example which include sp also. Now for sp, what it says, what our trick says, always p pi bond. Okay, always p pi bond. Let us draw a structure for this. This is your structure, linear structure with 180 degree. Okay, with 180 degree. Now what is the nature of the pi bonding? Always p pi bond. So always p pi bonding. Now how many bondings we have? 2, right? So I will be writing here 2. Similarly in this case, all will be p pi and d pi. How many we have? 3. So 3 I'll be writing here. Here we have 2, so I have written 2. Here we have 3, so I have written 3 here. Now I'll be giving you some homework questions. Comment me the answer below. Okay, you can comment me the answer below. Now first question is your SO3 and second question I'll be giving you XeO4. Now for this 2 questions, you tell me the nature of the pi bond of the oxygen. Okay, you comment me below and tell me, and if you don't understand, ask me, I'll explain you or make a. So hello students, in this video we are going to discuss a very important trick for Fazan's rule, and the trick is SCLA, which means smaller cation, larger anion. Smaller cation, larger anion, SCLA. Okay, now let us discuss this trick with an example. Compare the polarizing power of the cation. What is the trick? SCLA, smaller cation. See, we need smaller cation. Now if we go down the group, what is the trend? The trend is the size increases. Okay, now among these ions, which is the smallest ion? Lithium plus, of course, right? So this will be having the greatest polarizing power. That's what I have written here. The smaller the cation, the greater is the polarizing power and the greater is the covalent character. Similarly, if the larger is the anion, the greater is the covalent character and the greater is the polarization power. Okay, so I dedicate this trick to my chemistry sir, Tiwari sir. Thank you. This series is finding bond order. Trick to find bond order. Alright, so let us see the trick. In this video, I'm going to discuss how to find the bond order along with the previous year questions. Okay, now let me tell you. See, these are the number of electrons what I have written. Okay, these are the number of electron, and here we have to find the bond order. Now to find the bond order, first one number you have to keep in focus, that is 14. Okay, 14 you have to keep it, that its bond order is 3. See, like how you by had the constants, like the speed of light is 3 into 10 power 8 meter per second. You will by had some constants, right? In that manner, you have to keep this in your mind, that the bond order of 14, okay, the bond order of element which has 14 electron is 3. Then by keeping this as a constant, we have to increase or decrease for finding the bond order of this type of electron species. Alright, now let us move on. Top and bottom, both. How we have to approach is, we have to keep on decreasing the bond order with 0.5. It means, like, for if an element or a compound or a complex have 13 electron, then its bond order will be 2.5. What I have did, I have just decreased 0.5. In this manner we have to keep on decreasing. Okay, and below also we have to keep on decreasing. Getting my point? Now next, for 12, how we have to write? 2, because we have decreased 0.5. Then for 11, how we have to write? Tell me how we have to write? 1.5. Then for 10, 1. Then for 9, 0.5. And for 8, it's 0. Okay, in this manner we have to keep on decreasing as we go upward. Similarly we have to do if we go downwards. Alright, now 3 is constant as I told you. Again we have to decrease 0.5. Then for 15 electron species, bond order will be 2.5. For 16 electron species, bond order will be 2. For 17, 1.5. Then decrease 0.5. 1. Then again decrease 0.5. it will be 0.5. Then finally, if you decrease 0.5 from 0.5, for 20 electron species, bond order will be 0. And let me tell you one thing. For if you come across any species which has bond order 0, like for 8 electron species and 20 electron species, it means that the molecule does not exist. Okay, here I have written the point somewhere. I'll explain you. Now, see here. Till now, in the first page, I have covered the species which has electron 8. Now, what about the species which has below 8? It means from 1 electron to 7 electron. So, see here. For 1 to 7 electron species, we have another trick. Alright, what is the trick is, remember this word, BA. What is it? Baba, right? Baba, BA. Now, what it means is, B means bonding orbital, sigma 1s. Sigma star 1s, anti-bonding orbital. B means bonding orbital, molecular orbital. A means anti-bonding molecular orbital. B means bonding molecular orbital. A means anti-bonding. Okay. Sigma 1s is bonding. Sigma star 1s is anti-bonding. Similarly, sigma 2s and sigma star 2s. Now, we have to fill 2 electrons in each orbital. Okay, in sigma 1s, like in bonding orbital, you have to fill 2 electrons. In anti-bonding, 2 electrons. Similarly, Baba, 2 electrons you have to fill. Getting my point? Very simple. Now, let's come to the formula. What is the formula? See, for bond order, the official formula is half into number of electron of bonding molecular orbital. This one, BMO, minus number of electron in anti-bonding molecular orbital. Now, suppose, let me take an example for you to make you understand better. Suppose we have given a species in which number of electron is 4. Now, how we have to find the bond order? Write BA. What I told you, Baba. How we have to fill? 2 electrons each we have to fill, right? In bonding orbital 2, anti-bonding orbital and anti-bonding orbital 2. Now, we only have 4 electrons. How we have to fill? 2 and 2. In bonding orbital we can fill 2, anti-bonding orbital we can fill 2. Alright, now this 2 electron, that is equal to 4. We have already filled. Now how to write this? See, bond order is equal to half into number of electron in bonding orbital. How many electron? 2, minus how many electron in anti-bonding orbital? See here, how many electron in anti-bonding orbital? 2. So 2. Now half into 2 minus 2 is 0, therefore 0. Now see here, if bond order is equal to 0, then molecule does not exist. It means this type of molecule, where you got the number of electron 4, this type of molecule does not exist. And another important point, if the bond order is same, okay, if you come across 2 species whose bond order is same, then see how many number of electrons are filled in anti-bonding orbital. If one species has less number of electron in anti-bonding orbital than another species, then the species which has more number of electron in the anti-bonding orbital, its stability is less. Whenever electrons in anti-bonding orbital increases, then its stability decreases. Getting my point? So this is like inversely proportional. If electron in anti-bonding orbital increases, stability decreases. In this manner, you can compare. Now, let us come to solving some questions. See, all the questions I have taken from NEET. This is from NEET 2015, NEET 2017, NEET 2018. Okay, from JEE also I'll be taking some questions. Okay, stay tuned. Now, let us come to solving the questions. See, the correct bond order. We have to find the correct bond order. Now, let us take the first molecule, O2 minus. How we have to find 2 molecules of oxygen we have. In one molecule we have 8 electron, so 8 plus 8. 2 molecules of oxygen, right? So 8 plus 8. Now here we have minus. Minus means we have added 1 electron. If it was plus, then we would have subtracted 1. But here as we have minus, so we will add. Why? Because here it is minus. It means 1 electron already we have given to this molecule. Extra electron we have given to it. So 1 electron we have to add plus 1. Then what is the sum? 17. Now for 17, what is the bond order? 1.5. 1.5. Now let us come to O2, oxygen. Just 8 plus 8, 2 molecules. No sign plus or minus we don't have. It means 16. For 16, what is the bond order? 2. Right? So 2. Let's write 2 here. Next, O2 plus 8 plus 8. Now we have minus. It means we have taken one electron from this species. So we have to minus 1. Then it will be 15. It means for 15, what is the bond order? 2.5. Right, 2.5. It means this will be 1, this will be 2, this will be 3 in the order. Where you can find this order in the. Now next let us go to the question number 2. What question number 2 says, which pair of species have same bond order? See, in order to save your time, I'll just take the answer and I'll explain you. Answer is third option. Okay, let me explain you. Okay, Cn minus. It means in carbon how many electrons we have? How many electrons we have in carbon? 6 plus. In nitrogen how many electrons we have? 7. Now here minus. If it was plus, what we had did here? Subtracted 1. And as we have minus here, so we will add 1 because 1 electron is given, extra given to this species. Now 6 plus 7 plus 1, 14, right? So 14 electron. Now next let us take this CO. Carbon how many electrons we have? 6 plus oxygen how many electrons we have? 8. So 6 plus 8 is again 14. Now what is the bond order for 14? As I told you have to remember this. Do whatever, but you have to remember this. 14, 3. For 14 electron species, bond order is 3. Okay, it's like a constant you have to remember. So for both the species, bond order is 3. So which pair of the species have same bond order? It means third option. Okay, Cn minus comma CO, carbon monoxide, have same number or same bond order. Okay, now let us move on to the next question. This question was asked in 2018. Now we have to find the highest bond order. Which species has highest bond order? Now let us calculate. Carbon how many electrons we have? 6 plus nitrogen 7 plus we have, so minus 1, therefore finally 12. 12 means 2 is the bond order for this. 2 is the bond order for this. Now let us come to the Cn. Carbon 6 plus 7 nitrogen minus we have, so we have to add 1. Therefore it means it will be 14. Am I right? 14. Next for 14 what is the bond order? 3. Next let us go to the nitrogen oxide. N is 7 plus oxygen is 8. Are you getting what I am doing? Right. So if you add 7 plus 8 it will be 15. So for 15 what is the bond order? What I told you, 2.5. You have to decrease 0.5. After 14 we have 15, so we have to decrease 0.5. It means the bond order is 2.5. Next Cn. Carbon is 6 plus 7, nitrogen is 7, then therefore 6 plus 7 it is 13. So again decrease 0.5. It will be 2.5. Right. Now among this, which has the highest bond order? Option 2. Right, option 2 has the highest bond order. At last, let me tell you another important point. See, bond length is inversely proportional to bond order. It means as you increase the bond order, bond length decreases. If bond length increases, bond order decreases. It means Cn minus has the least bond length. Okay, Cn minus has the least bond length and Cn plus has the greatest or the longest bond. Now in this video I'm going to reveal some super tricks for dipole moment. See, almost once in a 2 year or once in a year they'll be asking you questions from dipole moment also. Okay, dipole moment is very important topic and many students will get confused in solving the problems from dipole moment. But it's not so confusing topic. Just I'll be telling you few tricks, few tips. Remember them, and any problem, any numerical, anything as from dipole moment you can solve it. within seconds. Alright, now let us move on to our tricks. See, I'll be telling you a few points, remember them carefully. Dipole moment is directly proportional to the electronegative difference. The more the electronegative the element is, the more the dipole moment it has. For example, let me tell you one example. Suppose we have, first example, HF, HCl, HBr, then HI. Now, if they ask you to calculate the order of dipole moment, how we will be doing it? Tell me one thing. Among this element, which is the element which has highest electronegative, which is the most electronegative element among this following elements? Fluorine, right? So HF will have the greatest dipole moment. Next, among Cl, chlorine, Br, bromine, which has the highest electronegativity? Chlorine, of course, chlorine, right? So HCl is greater than HBr. Similarly, HBr is greater than HI. So this is the order of the dipole moment. The more the electronegative element, the more the dipole moment it has. Next point. Dipole moment is directly proportional to the number of lone pair of electron. See, the more the lone pair of electron presents on the molecule, the more dipole moment it has. Okay, let me tell one example for that also. Suppose we have H2O. What is H2O? Water, and NH3. See, on water, on oxygen molecule, we have 2 lone pairs. Am I right? Now, in nitrogen, on nitrogen we have 2 lone pairs. On oxygen we have 4 lone pair. On nitrogen we have 2 lone pair. So, which will be having the greatest dipole moment? Water. See, because there are 2 lone pair. The more the lone pair of electron, the more the dipole moment, because it's directly proportional. All right. Now next, dipole moment is directly inversely proportional to the angle. What it means? See, when you read organic chemistry, you will come across some shapes like you have ortho, right? You might have heard this, meta and para. This is para. Okay, now we have these 3 shapes: ortho, meta and para. And in ortho we have angle of 60 degree. In meta we have angle of 120 degree, and in para we have 180 degree. Now what my trick says, dipole moment is inversely proportional to the angle. It means the more the dipole moment, the lesser the angle. The greater the angle, the lesser the dipole moment. It means ortho has greater dipole moment than meta, meta has greater dipole moment than para. So this is the correct order. Now indirectly or directly they will be asking you questions based on this concept. Okay, they'll give some concept, they'll give some problems, they'll give some shapes including benzene, where we have ortho, meta, para directing groups, and they'll be asking you to arrange in the correct order of ortho and in the correct order of decreasing or increasing power of dipole moment. Then what you have to do, ortho is greater than meta is greater than para, because we know the angles, right? So angle is inversely proportional to the dipole moment. Next, let us come to the next point. See, dipole moment of homoatomic molecule. Homoatomic molecules means like we have nitrogen N2, H2, O2. See, for this type of molecule, the dipole moment is always 0. Keep this in your mind, very important. For dipole moment of homoatomic molecule like nitrogen, hydrogen, N2, H2, O2 is always 0. Next, the dipole moment of molecule having geometry is 0. Okay, molecule having geometry, its dipole moment is always 0. Like what? Linear, trigonal, tetrahedral. See, in my previous video, I have already explained you all those things. In my previous video, I had told you how to find the hybridization, and I had explained 3 methods. How many methods? 3 methods. I had very cool and amazing 3 methods I had explained you to find the hybridization, and I had already told that among these 3 methods, whichever method you find it comfortable, you can use that. Okay, now if you want to watch that video, I'll provide the link for that video finding hybridization in the description. You can check that video. Next, I had already explained the trick and tips to learn and to remember the shape of the molecule. Okay, they'll give one molecule and we have to find and we have to write the shape of that molecule, whether it is trigonal, planar, tetrahedral, trigonal, bipyramidal, octahedral. See, most of the students will get confused in recognizing the shape, but on that topic also I have made a super cool video. Okay, if you want to watch that video also, I'll provide the link for that video. Okay, you can watch that video also. See, for trigonal planar, which has hybridization sp2, dipole moment is 0. Similarly, for tetrahedral, trigonal, bipyramidal, octahedral, which has hybridization sp3, sp3d, sp3d2, for all these kinds of molecule which has this shape and hybridization, dipole moment is always 0. Okay, dipole moment is always 0. Alright, now let us come to the next point. Molecule in which central atom having lone pair, like pyramidal, seesaw. Remember, very important, molecule having central atom having lone pair like pyramidal, angular, seesaw, those dipole moment, those molecules dipole moment is never 0. Never 0. Remember this. Whoever has lone pair atom, those molecules are never 0 if they have pyramidal, seesaw type shape. Okay. Now let us come to another point. Dipole moment of cis alkene is greater than trans alkene. Why? Because in trans alkene the atoms are situated or atoms are arranged in such a manner that they cancel out. Okay, the dipole moment acts in opposite direction. When they act in opposite direction, both cancel them. Okay, as both cancel them in this manner, then the total dipole moment of trans molecules, maximum cases it will be 0. So therefore dipole moment of cis alkene is always greater than trans alkene. Next, let me discuss another last important point. See, if the lone pair are in opposite direction, then the dipole moment is always 0. See, here I have discussed molecules in a central atom having lone pair like pyramidal, seesaw, this shape. But here what I am telling is, if lone pair are in opposite direction, we have pair. If we have pair of lone pair are in opposite direction, then the dipole moment is 0. Let's take this example. This is a xenon molecule. Okay, this is a xenon molecule surrounded by 4 fluorine atoms. This is one fluorine, this is one fluorine, this is one fluorine, and this is one fluorine. Okay, now focus on these 2 fluorines. See, the dipole moment. Now focus on these 2 fluorine atoms. See, the dipole moment of this fluorine is acting in this direction and the dipole moment of this fluorine is acting in this direction. So they both are acting in opposite direction, therefore they both cancel out each other. They both cancel out each other. Now focus on these 2 fluorine atoms. See, the dipole moment of this fluorine is acting in this direction and therefore the dipole moment of this fluorine is acting in this direction, opposite to each other. Therefore they both also cancel out each other. Now at last, focus on this lone pair atom. Whenever you come across this type of molecule in which lone pair are arranged in this manner opposite to each other, remember they both cancel out, because the dipole moment of this lone pair, upward direction is acting in upward direction, and for this lone pair it's acting in downward direction. So they both also cancel out each other. Okay, they both also cancel out each other. Therefore the net dipole moment will come to 0. Okay, now in this manner I have discussed with you some important, most amazing tricks and tips regarding the dipole moment. If you keep all these tricks and tips in your mind, definitely you will solve any question asked from this topic. Okay, so thanks for watching. If you like the video, don't forget to hit the like button because it motivates me a lot. Okay, hit the like button as well as subscribe my channel. Stay tuned, I'll be uploading still some more amazing, cool, magical tricks from chemistry, physics, mathematics as well as biology. Okay, stay tuned. Thank you for watching. Thank you.